everyone. Thanks for coming to this talk. One word of warning. The room over is going to play a lot of music. So I'd like to apologize on behalf of the speaker next to me. If need be, I'll just shout, but just be warned. So in this talk, I'm going to help you understand the fundamentals of CSS. But before doing so, I want to get a little show of hands. Who here thinks that CSS is difficult or hard or weird to work with? Cool. And who here thinks they have a good grasp of CSS, that they really understand what's going on? Okay, that's good. We'll see. So when you look at CSS as a whole, it's a very complex system that's hard to understand. But it's also a system that works. And there's a law called Gall's law that states that all complex systems that work evolved from simpler systems that work. And that's the case for CSS as well. It started as a relatively small, self-contained system. It started as a single layout algorithm called normal flow. Now, normal flow has just a few basic rules, which all subsequent concepts in CSS are built upon. And once you understand those concepts, you can see the matrix. In other words, this talk will help you go from this to this. So, quickly, who am I? I'm Kilian. I've been developing websites for about 20 years now. I used to write a lot about understanding CSS, mostly for myself. Looking back at these articles that I wrote in 2008 is hilarious, because at that point, CSS Grid and CSS Flexbox weren't a thing yet, but people were thinking about it, and they were calling it the Advanced Layout module. And if you read the specs from that time, it's nothing like CSS Grid that we got today. And you should be happy that that's the case. I also make a browser for developers called Polypane. It helps you with responsive design, accessibility, and general website quality. It looks like this. It gives you a ton of really cool tools to test and debug CSS. And this talk isn't about that. So if you're interested to learn more about Polypane, come talk to me afterwards. So we'll go over the fundamentals of CSS roughly in the order by which they were introduced. That way we can learn how they build upon each other. And the most fundamental concept in CSS is that everything is a box. Each element in CSS creates a box, and the X and Y, the width and the height of each box together determine the layout of your page. Now, stating that might feel obvious, but you need to understand that before screens were a thing, the idea of a live layout algorithm wasn't really something people needed or used. Of course, print pages are laid out, but they're laid out once, and then they never change. None of those things happen in real time based on a system of rules, which is what CSS is. So CSS is a bunch of boxes. But what's the layout algorithm that places them on the screen? That's normal flow. Now, normal flow is the first and simplest layout algorithm in CSS, and it's the one you get when you don't do anything. It's from when the web was made for documents, and normal flow is essentially the way text flows across a page. It goes from left to right, top to bottom, for Western languages, of course. But I won't get into multilingual layouts in this talk. So from left to right is what we call the inline direction, and top to bottom is the block direction. So text characters will be inline because they're side by side, but things like paragraphs and headings are block because they sit on top of each other. Now, browsers ship with a default CSS style sheet that dictates which elements are block and which elements are inline by default. For example, a p tag for a paragraph has display block, but M for emphasis has display inline. This means that if you write semantic HTML, the browser already makes it look like a document for you. So block and inline will tell you how given elements lay out in comparison to other elements. But not everything is an element. For example, in this bit of code, P is an element and M is an element. But what about this is? How does that work? Well, with more boxes. The browser creates something called an anonymous box for everything that isn't self-contained in an element. So in this case, the box you see here is an anonymous inline box because the M is also an inline box. Now the browser has all the information it needs. It has two inline boxes, and it can lay it out side by side. This is called the formatting context of an element. So the formatting context is either it's inline or it's block. So if the code was this, a div with a paragraph in it, both the div and the paragraph are block level elements, and that means that the anonymous box being generated for this is also block because it sits next to a block box. And then the browser knows that it should lay out these two elements as block layouts, creating these hidden anonymous boxes. So when you know about anonymous box generation, you can also start to understand why some things you might expect to work don't. For example, here I have two divs that sit inside a div, and I give them a width of 50%, and I tell them to be inline. So 50% plus 50% is 100%. That means they should fit, right? That's basic math. But the browser creates anonymous boxes. So the white space between the first div and the second div creates an anonymous box of the width of a space. That's over there. And now we can clearly see that 50% plus a little bit plus 50% is more than 100%. And so the second box ends up on the second line. Now, the ideal thing would be for us to hide that anonymous box. But CSS is built in such a way that you can't target anonymous boxes. You can only target elements or selectors. So we need to do something else if we want to make this work. And there are a couple of different strategies that you can employ to deal with it. Firstly, we can just change the DOM structure so that there's no more white space between the two divs. So you can see that I've literally removed the space between the two divs, and now there's no anonymous box being created. And you can see that they both fit. This is real HTML, by the way, so no cheating. We can also do something like white space no wrap. This tells the browser that even though there is white space that would normally cause elements to wrap to a next line, to ignore that, to not wrap or no wrap. You can see that they now sit on one line, but there's still some space between them, and the second box actually overflows out of the parent element. You can see that the total of all the boxes is now wider than the parent element. What we can also do is set the font size to 0. When you set the font size to 0, there is still an anonymous box of the width of the space, of a space in your font. But if the font size is 0, then the space's width is also 0, and now the boxes fit. Of course, remember that if you have actual content in these boxes, to put the font size back to something decent for these elements, otherwise you'll spend some time figuring out why your text isn't showing. This has never happened to me. I'm not taking questions. Now, the last thing you can do is tell the browser explicitly how to deal with whitespace, how to deal with anonymous boxes, with the whitespace collapse CSS property. There's, and then the discard value. Now, to show you how much CSS is still being worked on, whitespace collapse is part of the newest CSS specification, CSS text level 4. Right now, whitespace collapse is only implemented in Chromium, and I'm cheating here, because even though whitespace collapse is implemented, discard isn't. So the only thing they implemented is the behavior they already had for the past 25 years, and added whitespace collapse as a known property. But it does mean that even normal flow, which has been around since the beginning of CSS, is still being worked on. It's not just Flex and Grid that are getting updates. It's the very basis of CSS that we're still improving to this day. Let's zoom into boxes. And this is where I talk about the box model. You've probably seen something like this before, because a box in CSS actually consists of a few distinct areas. Now, for stupid browser reasons, there are two models when it comes to determining the size of a box: content box and border box. One of those is the default in all the browsers, and the other one makes sense. Sorry about that. So the default is content box. In this situation, if you set a width for a box, that width is just for the content. Padding and borders are added to it. So if you want to find out the actual width of a box, you'll have to do some math. We're stuck with this as default, as I said, which is why most CSS reset style sheets do something like this, where they set the box sizing to border box. Now, the actual width of the element is the width that you set in your CSS. And any padding will be inside of that width. So if you set a width of 200 pixels, then your box is 200 pixels. That's a little bit easier to work with. Now, padding and border are always inside the box, while margin is outside of it. There's a lot to say about margin, and we'll get to that in a bit. Everything in CSS is a box. I've been saying that quite a lot now, but I want to drive the point home. However, a box isn't always what you expect. So a block element box makes sense. It's a rectangle, and the border sits at all the edges. But inline elements can wrap to the next line without becoming a block element. A text will run to the next line. And so the box around an inline element has to be split up across lines. Now, as you can see, this box has borders on all the edges, but not in the way that you expect. The top and bottom borders are drawn for each line, while the inline borders and padding, so the one on the left and the right, are only drawn at the start and the end of the line. So the box, the inline box, is rendered as one long single line, and then it is sliced up to fit into subsequent lines. Nowadays, we can tell browsers how to treat each broken up line with box decoration break. So the default value here is slice, where you take that long inline text and you slice it up into separate lines. But if you set it to clone, you will see that each line itself becomes its own box. We get borders and padding on each side of each box. Everything is boxes and lines. So what is a line? Each box in CSS is split up into lines based on the line height of your font. That's this thing. And then each line has something called a baseline, which is determined by the font you use, that all inline elements sit on. So that's here, it's at the bottom of the text. Now, baseline is the default vertical alignment, which is where text sits inside of the line. But you can also align to top, to the bottom, and to the middle. Now, the top and bottom, as you can see, aren't the top and bottom of the entire line. They are the top and bottom of the font. You can see how top aligns with the dot in the I, and how the bottom of bottom almost aligns with the bottom of the, or the descender of the P. Then there's middle. Middle is weird because it's calculated from a combination of font metrics and the line height you set, and it doesn't always mean the middle of the line because it's a combination of the middle of the line and the middle of the font. And if you look really closely, you can see that here, where there is slightly more space below the word middle than above the word middle. And this is the source of frustration for many. And I'd like to apologize for that on behalf of CSS. And we're just gonna pretend that this doesn't exist. So, inline elements sit on the baseline. When you know that, this suddenly starts to make sense. The image sits on the baseline. And so we get white space below it. If I would put the letter P next to this image, the descender of the P would dip below the image. Now you know why there's this weird space below images. So how do we deal with that? Well, something we can do is add display block to it, because block elements don't sit on the baseline. So this removes the image from the line, but you can see that it has other effects. Now it's all the way on the left, and it no longer follows the rest of the text. Maybe we don't want that. What we can also do is get rid of the line height. If the line height is 0, then there's no space below the baseline, because that's then also 0, and we get rid of the space as well. Now, if you now add text to this, things can get really weird. So there's a very simple solution to the image problem, and that's just take it off the baseline. Set a vertical alignment to top or bottom, and now it's no longer aligned to the baseline. The baseline is somewhere, but it doesn't matter because you're not aligning to it. So that's how you solve that particular issue. And I think this actually makes a lot of sense, but it begins with knowing that text and images sit on the baseline. So, more weird stuff. Margins. Now, margins are outside of an element, and they help push boxes apart. For block elements, this happens in all directions. But inline elements, they sit on a line, and that line determines their placement. So adding a margin to them will only add it in the inline direction. So only the left and the right side can have margin applied, because the vertical alignment is determined by the line it sits on. Now, there's more weird stuff when it comes to margins. margin collapse. When there are two block elements with margins sitting above each other or on top of each other, the larger margin of the two is picked and they collapse into each other. So you can see here that, any reasonable person would look at this and say, okay, margin top 30 plus margin bottom 10, 40 pick spacing. But in CSS, when two elements sit next to each other, what happens instead is that they collapse the margin into itself, so the largest of the two wins. And that's not just for elements that sit next to each other, but this happens for any two elements in something called the formatting context, which you might remember from the anonymous boxes earlier in the presentation. So whenever two elements are in the same formatting context, and they have margins that interact, so they're either on top of each other or they're in the same place, margin collapse can happen. So in this situation, I have an H1 inside a div, and both of them have a margin top, and both of those margins, because they're in the same formatting context, sit outside of the div. You'll undoubtedly have encountered this at some point where you wanted to add space above a heading inside a block, and suddenly you added space above the block, or the block moved along with your heading. And you might have solved it this way. Just add a little bit of padding. Because margin collapse only happens if there's nothing else in between it. If there's a border or a padding in between, there's no margin collapse. But what you can also do is be explicit about your formatting context. You have control over this. By setting an explicit overflow strategy with overflow auto, for example, that creates a new formatting context for inside of your div. Now, because margins only collapse when they're in the same formatting context, and now we've created two, one for outside of the div and one for inside of the div, the margins no longer collapse. But margins can also be negative. Now, when you use negative margins, you aren't actually adding space between elements, but you're changing the position of an element itself, which is a little weird when you think about it. The way these get calculated is they figure out the collapsed margin value, which is -20, and then subtracting the other margin, which is 10, and then they start the new element there. So the blue element is initially moved by 20 pixels and then pushed down by 10 again. And that's where the actual element ends up. Now, I'm showing these slides because negative margins exist, and let's leave it at that. It's better off never using a negative margin. You want to use positioning instead, and more on that later. Because there's more you need to know about the basic layout in CSS. And that's when you use percentages. When you use percentages in CSS, what is it a percentage of? For width and height, it's a percentage of the width and height of the offset parent. And I'll explain what that is in a bit. But when you use a percentage for padding or margin, it's always related to the width, even if you use a padding top. And this is because most elements in CSS have a height that's determined by their children. If you add text to an element, the element becomes longer. Or, in other words, a paragraph is as high as the number of lines needed for the text in it. So if you then add padding as a percentage of the height, the number of lines might change. That causes a change in what the size is which then causes a change in what the percentage of the size is, and that could cause an infinite loop. And the quickest way to deal with that is just to say, well, anything that changes the height in percentages uses the percentage of the width of your offset parent. So margin and padding will always be 50% of the width of an element, even if you have a margin top or margin bottom. Margins can also be auto. And this is an entirely new paradigm, because when you want to horizontally center a block level element, you can add margin auto. And it will add the same amount of margin to the left and the right of the element, which results in it being centered. This works because horizontally, block level elements use something called a constraint-based layout, when you have either width or margin set to auto. Now, this is the official formula. So the total width is the left margin plus the border plus the padding plus the width plus the right padding plus the right border plus the right margin. But because borders and paddings are fixed values, we can simplify it to just this. The layout, the horizontal layout, is the left margin plus the width plus the right margin. By default, all of these are auto, and that means that width will take up all the available horizontal space, because width wants to be 100% for block level layouts. That's called the preferred width. So the formula you get here is margin will be 0, width will be 100%, and margin right will also be 0. And this is the end result. When width is fixed, however, if the width is a known value, the remaining space is divided across the margins. So if both are auto, they get the same percentage. But if one of the margins is defined, the other gets set to the rest. You can see here how the element is right aligned, despite elements normally starting on the left. And that's the constraint-based layout in action. Because margin right and width are known, margin left is expanded to fill the remaining space. So there's one last trick that normal flow has up its sleeve, and that's that an element can also be inline block. Given all the time we spent figuring out the difference between inline and block, what's inline block? Well, inline block tells the browser that a given element behaves as inline for the formatting context around it, but is rendered itself as a block box, and that then creates its own formatting context. So you can see that it sits on the line, and the element is as wide as the content, but you can still apply margin, padding, etc. to the box. And the specification calls this shrink to fit. Now, before Flexbox, this was the way to render, for example, a list of tags. Okay, time for a breather. Because this was CSS' simplest layout algorithm. Would you have expected there was so much behind? Essentially, text goes from left to right, top to bottom. Now, the good news is that all the other layouts build upon this concept. In fact, unless you explicitly take an element out of flow, out of normal flow, they are considered in flow, and the normal flow algorithm is used in addition to whatever else you use. Well, here's the whatever else. We've had normal flow. You can also do table layouts, you can do float-based layouts, you can set positioning, or use flex or grid. We're not going to talk about tables or floats, because using them for layout was always a hack, and we haven't needed those in well over a decade. With positioning, we can tell the browser how to place an element, either in relation to its calculated flow position, so where normal flow would have placed it, or by explicitly taking it out of normal flow. And it's also the first place where the third dimension is introduced into CSS. That's right, normal flow doesn't have a third dimension, but positioning includes z-index. And with it, we can decide how elements stack on top of each other. Now, elements by default have a value of static, which means they have no explicit positioning. And to activate the positioning layout algorithm, we need to pick any of the different values. Now, each value is something called a scheme, a different scheme that makes your elements behave differently. Positioning relative, or position relative, is the basic value that lets you opt into this positioning layout algorithm. A relatively positioned element will have a box that's placed in the same place as normal flow, the dark box you see here. And we can then use top, left, bottom, and right, or inset, to move the element away from that box. Now, this is different from margin, because margin will push the other boxes away. Whereas here you can see that the original box takes up the space and pushes the text down, but your offset box, your relative box that you added a top and a left to, is on top of that. It doesn't interact with the rest of the page. Now, you'll rarely want to do this. You'll rarely want to add position relative and a top and left value. But what you do use position relative for is to very explicitly opt this element and all its child elements into this positioning layout algorithm, because it makes it an offset parent, that word again. Before we get to that, I quickly want to explain position absolute. When elements with position relative are still part of normal flow, position absolute elements are taken out of that normal flow. And that means that they do not interact with other elements. In the DOM order, they're between these two text lines, but you can see that it's all the way up here. Now, inset doesn't move them away from their reserved space, like relative, but places them in relation to the offset parent. And now we get to what even is an offset parent. So the offset parent is the first ancestor, so the first element above it, that is also positioned, that also has a position. And that's what absolutely positioned elements are positioned in relation to. So by default, your body element is the only offset parent in your page. So when you have an element with position absolute and set its top to 0, it will be at the top of your body element, the top of your page. But if we then add positioning to the parent element, we make that the offset parent. And since that one is closer to your absolute element, it now becomes the element to be positioned against. And top 0 will now be the top of the parent element, and no longer the top of the page. Position absolute itself also makes an element an offset parent. In fact, any value other than static will do so. Now, when you use position absolute, and it's not being placed where you think it should be placed, offset parent is the reason. It's because the offset parent is different from what you think it should be. And if you run into that, you can open your console and check the offset parent value of an element in your console, and that will tell you which element is the offset parent and will help you debug this layout. Now, fixed is much like absolute. Elements are taken out of normal flow, but in this scheme, the offset parent is always the viewport. And top, bottom, left, and right are used to position from the edge of your viewport. So it's no longer interacting with the page or the body element. And that means while absolutely positioned elements will scroll along with the rest of your page, fixed elements will always stay in view. because they no longer take the scroll position of the page into account. They just look at your viewport, which is your browser window. That leaves position sticky. Position sticky is very new relative to the other positioning values. And it's for elements that you want to keep in view for some of the time, but still want to scroll along with the offset parent. So with position sticky, initially the element will be relatively positioned. It just scrolls along with the page like any other element, until it hits the top left, bottom, or right value that you set in your CSS. Once it hits that value, it becomes stuck, which is where position sticky comes from. So at 100 pixels, now it's stuck. And it will remain stuck until the parent element, until the parent element takes it away again. So if the parent element scrolls outside of the place where it can get stuck, so beyond that top 100 pixels, it will just take the element with it. Now, a tricky thing here is that it can only get stuck if it knows how to get stuck. And that's determined by the browser in a few different ways. And there's 3 scenarios that can cause this to go wrong. If you have a parent with an overflow other than visible, so auto, scroll, or clip, or hidden, then the browser doesn't actually know when it will hit that top 100 pixels, because the browser can't generate that. If your parent element doesn't have a fixed height, then again, the browser can't determine when you hit that edge. And the last one, if you have a sticky element that's larger than your viewport, then it also can't get stuck because it needs to show the entire element for it to get stuck. So those are situations where your sticky element might not end up getting stuck. Now, so far, we haven't yet discussed the third dimension, other than mention that it's there. So while the concept of an offset parent tells you how an element is positioned in the X and Y direction, something called the stacking context tells you how it gets positioned in the third dimension, how close it is towards the front of the screen. And like offset parents, you can also have stacking contexts in stacking contexts. So by default, the stacking order, the order of elements, is the same as the source order, so your DOM structure. And then you can use z-index to change that around. Now that reordering only happens inside a stacking context, and there's no way to break out of that. So you can see here that even though my purple inner box has a z-index of 99, it's still behind the blue one, even though that only has a z-index of 2. And that's because my inner is inside this first div with a z-index of 1. And because 2 is more than 1, it will always be, it doesn't matter how high your z-index inside of that first element is, 2 will always beat 1. Or in other words, 1,99 is less than 2, so it'll be behind the z-index of 2. Now, offset parents are very easy. They are created by positioning. Stacking context has a few more things that can trigger it. This list makes offset parents sound easy, right? It's quite a list, but luckily, most of these properties aren't used very often. You're probably not using mask image or contain very often in your CSS. So the things to look out for if you're dealing with stacking issues are these 3: position, z-index, and opacity, where opacity is most often the culprit, because once you add opacity to something, it also becomes a stacking context. That's not very clear in most situations. Now, out of all of the options I just showed, isolation isolate is the most explicit way to create a stacking context. So let's dig into how that works. For this example, I have a design with a quote here. And after positioning it correctly in the X and Y direction, you can see that the quote is in the right place, but it sits on top of my text. Now, the text doesn't have any element around it. It's just inside the block quote. I can't pull it forward because it's an anonymous box. So instead, we need to bring the quote backward, which we can do with a z-index of -1. But when you do that, the quote disappears behind the parent because the stacking context is the HTML element. So we pulled the quote all the way back to being like the first element in your page. So what we need to do here is make the parent element a new stacking context, which we can do with isolation isolate, and which you can see here. And when we do that, you can see that the quote is now inside of the parent element, but it's behind the text. So it's in the place we want it, and we've done so by explicitly setting a stacking context. Now, finding the stacking context parent is not as easy as finding the offset parent, because there's no stacking context property of an element. But in Polypane, there is a debug panel that will show you the stacking context parent. So this is all the promotion I'll do, but please check it out. So now you know the fundamentals of CSS layout. You know about the different types of context something can have and how that affects where elements get positioned. You've learned how normal flow dictates element placement and how display and position allow you to opt into different placement schemes. Now, flex and grid are built upon these fundamentals, but don't replace them. I don't have a lot of time to go over them, and I definitely don't have time to explain them in great detail. Some other things that I could have also mentioned in this talk, but then it would be like a day-long course, is viewports, units, and the overflow property. So we're just gonna pretend that they don't matter. So flex and grid are significantly different layout algorithms, because while normal flow and positioning are made explicitly for documents, grid and flex have been developed for designing web applications. And conceptually, there's really one difference between flex and grid, like apart from the syntax. With flex, you get a bunch of elements, and you order them in either a row or a column. And with grid, you set up a two-dimensional grid of areas, and you place elements inside of them. And that means that in flex, elements determine their size, and in grid, grid determines the size of the elements for you. Both of them try to make sure that regardless of what element you put inside of them, the layout, as you've described it, is preserved. And that means that, for example, if you set a width of an element, and it doesn't fit inside your flex layout, or it doesn't fit inside your grid area, that width will be overwritten, because the layout is more important than your explicit width. Now, since both flex and grid are display values, so you set display grid and display value, the way to determine the offset parent and stacking context for elements inside of them doesn't change. It's still the same layout algorithm. And you can also take elements out of a flex layout or out of a grid layout with position absolute or fixed. Now, one thing that flex and grid make radically simpler is aligning, and especially vertical aligning. That's because, unlike vertical alignment in normal flow, which happens on the line, Flex and Grid don't take the font into account when aligning things. They just look at the middle of the box, and that's where your element sits if you set it to the middle of the box. It's a mind-breaking concept, and they introduced that in Flex and Grid, and it worked so well that you can now also set align items in any display block box, and it will also work there. Browsers have landed that just a month ago. So now you don't even need Grid or Flex to align items vertically. So vertical centering solved everywhere where you want to use it. So those were the fundamentals of CSS Layout. You can find me on Twitter as @Kilian Valkhof, and thank you all for listening.